Welcome to class 34 of Python programming, and this will be fourth class of pandas. I'll take you through the very basics so that it will be useful for you later in data analysis. We'll discuss some important topics today of pandas. You can check this one, Word file. If you check here, remember pandas data frame. This is pandas data frame, and this is pandas series. If you see this one and this one, you remember panda score is common because you will come across 500 times, maybe 1000 times in the next 2 to 3 years. These structures, these are so important. Whatever work you work in bank, you work in insurance company, you work in stock market, wherever. This format is very important. If you check the difference, standard Python and Jupyter, when you are using Jupyter notebook, then you see this way. You remember here one, you see the background. In the second row, you see the background. There is a little bit difference, right? There is a shade here, okay? Shaded. So here it's white and the background is shaded here. So that way, if you check, you will get always, whenever you see someone, you will know that, okay, it's from Jupyter notebook or Jupyter lab. Now coming to this one, we have Jupyter Hub also. Now standard Python format is normal, row column structure, Excel file structure, okay here. Coming to the difference between series and data frame, this is a recap. Frame, here series, small a, small f. And here D is in capital, data frame, F is in capital. Here S is in capital. Even if you do some turtle, I didn't do that for you. There also we have small t and capital T. Now, here if you check, index means always you need to remember, though it's not new now. But then, as I said you, this is a recap to you. Index. This one is the index. Even we'll use this in today's class. And these are column headers or column labels. And then this is your data. This whole one. And here data, same thing, no difference, label. Index also, pandas series, there is no difference, only little bit spacing here, and alternate rows are shaded. If you come to this type, the index is the same, the first one 0 to 9, and then you have data, only one column here, data, here many columns, that is the difference. But there is a difference between series and frame in any case. Even if you have one column here, if it's a data frame, it's different from series. If you have one column, you are doing something in one column. Suppose you want to forecast how many COVID patients will come tomorrow. This is a number anyway, and you would like to write a big number here, around 25,000. So one column is sufficient. We don't need many columns for that. It's like horses for courses. If you need one column, you need not go to data frame. However, in one column, you'll have little bit things to do. Let's go to the notebook here. This is a recap, as I said, for the initial 10 minutes. You have a list here, and you want to create one data frame. This is our first data frame. You just write pd.dataframe. PD is here, and that list you write here. You get your data frame. Check the type also, although you have one column, but this is frame type. Okay, your data frame, this type, because we created data frame. Go to the second one. Here Amit 10, Ramit 12, Rachit 13. You can write a list from that also. You can create a data frame. This is optional. Column name is optional. Even if I don't write this, then also let me delete this one. Okay, do this. So automatically you get numbers here 0, 1, 2, 3, 0, 1. So your data is list of list. That's all. You need not write a dictionary here. Even you write list of lists, then also you get your data. You can import data from your system, CSV data. You can get it from any website. We'll do that later through API keys. Now coming back to this one, here suppose you want another column. Okay, you see Amit comes here, Ramit comes here, Rachit comes here. If you write another one, that means you are increasing row. If you write numbers, more numbers here, 100, 200, 300, that will come here. That will be your second column. Okay, I mean the index is second, but that will be your third column. This is not column. Okay, this is first column, second column, and third column. Now if you run this one, you get this. Then come back to this one. This is very easy. This is a dictionary. We've written only XYZ. And then here you have a list. When you do this way, what will happen is you need not write specially this one. You got name and age here. You have to write columns. Okay, this is a part of your syntax. You check here, you run this, you get XYZ here. Nowhere you mentioned. If you have a dictionary, automatically, as I already explained you before, so these names will come here. Now come to this one. This is your key of this dictionary. Data is your dictionary. So we've written dictionary here. This dictionary has two keys. Okay, that's why you got two columns here. And we have four names and their attributes, whatever. Suppose age is one of them. So we have written this way, row and column. Now suppose you don't like the numbering 0, 1, 2, 3. We'll see today in the class when we'll not like 0, 1, 2, 3. Would like to have something here. Then you can write index data, whatever data you have, the dictionary data. You need not write columns here because you've already taken one dictionary. The next thing you can do is you just write index so that this will come here, index and columns. Now we'll get through numpy. Random.seed if you write, any code you write, then things will not change. So this will check what is this. Okay, let's run here. NumPy we have to import. So you make it 10, suppose. We've written 1000. So we have 10 numbers. Anu, you tell me how to find the mean of these numbers. How can you find the mean? If you want, you take this one. It will be easier for you. You tell me what is the mean. If I find the mean, what I will get. Anyone? Okay. You take A here, then find mean of A. Is it possible? Try. Mean is not defined. Why mean is not defined?
Maybe like import statistics and we should use mean.
Okay, you are in base Python now, but we are in NumPy. You check the type of A before finding mean. Whenever you have any doubt, it's a NumPy array. Okay, mean is a NumPy array, so you have to see directory of NumPy. Then only you will be able to know. In NumPy, it's there mean. So because we imported NumPy as NP, you need to write np dot mean. Np dot mean A. If you run this one, then you will get 0.09. What is expected here? Because this is a standard normal distribution, we got 10 standard normal numbers. Okay, let me print A as well. Yeah, I mean that's not required. Mean should be 0. It's around 0. 0.9 is not very big number, but then still it's not a very small number also. You got negative because 68% observation, 67.75 to be precise, numbers will be 0 minus 1, 0 plus 1. This is mu, this is sigma, 10 numbers, right? So mu minus sigma to mu plus sigma. So minus 1 to 1, 10 numbers you will get here. Run once again. See, these are very small, around 0. Still not very, very small. Sometimes 0.13 is not very small, maybe. So you try with 100 standard normal numbers. Maybe, yeah, this is small. But yeah, two zeros is good. 1 0 is not that good. Okay. So if you continue here, you have still a big number. So let's do more. Here we got this 2 zeros, that's fine. I'm not printing because it's a lot. Yeah, in 2 zeros we got. Okay. So if you take large numbers and you take mean, then you will get a number around 0. So simulation normally works when you have many numbers. Even if you want to increase 10 times more. See, this is very close to 0. This is very close to 0. Sometimes negative, sometimes positive. Standard normal, how many numbers? Here 10,000, 1 lakh, 1 million numbers. Okay. I mean, 1 million numbers you have taken and we found the mean. It's very close to 0 now. But what is central limit theorem? In central limit theorem, we don't find mean once. You have to find mean like this many times. Then take the mean of those. That should be exactly 0. That is central limit theorem. I've taken only once these numbers. I found the mean. But you have to take many times. So you have to run a for loop, and you know already we have done that. I'm not going to that. But this is like we checked A. This is a numpy array. So numpy array means you have to write np dot mean. Then you get the mean. Now my question is, suppose you don't want to write np dot. Can you change something and you find mean still? Is it possible? If I write from numpy import mean, can I write like this? Then I will write this, then I will get it. Is it possible? Let's try. This is another way. From numpy, import mean and use this one. That means I am taking from numpy only mean and I can find this one. You don't need to write dot here. I think you understand this, right? Suppose I cut this one. Will it work? Because you will come across these things hundreds of times here. From numpy, import mean. How it's working? It's working. You have to write both. Okay. See, Jupiter sometimes will put you in trouble. I'm 100% sure. Okay. So remember, whenever there is a problem, run from here. Kernel once again. Restart and run all. What I wondered is NP is not available, still it's working. That happens here in Jupyter notebooks. Like if you change a website, immediately it will not reflect in your browser. Okay. So you have to try from there. What I'm saying here is, though I imported mean from NumPy, I don't want to, get the whole of whatever, whole of thing. Then from that you find something. I just take mean and I can do that. It's a better way. That's fine. However, I use NP here. So you have to do both. If you have used up NumPy before, you have to write this line, this line. Okay, these kind of things you will come across for sure hundreds of times. So you will wonder why we have taken NP once, again we are writing this way. Because we use that way. Okay, so this is the standard. Otherwise, let's go to main thing. So we have seen this. Okay, easy. Now here through NumPy you have to get 10,000. N is 10,000. So I have x1, x2, x3, and it's a dictionary ABC x1, x2, x3. Now you got this way where I have to run it. So how many you got here? 1,000. Okay. So these all are random now. How many rows you have? 1,000 rows you have. So you have a very big data. Big means using NumPy 1,000, you can make it 10,000, 1 lakh, 10 lakhs also, not a problem. Okay, immediately in 1 second you will get. These are random numbers. Okay. Again, remember, this will be used today. This is index, the first one. There are only 3 columns, and this is column ABC, column names. Now, from here, we'll use everything. Whatever I discussed, that was kind of a recap. Okay. Here you see country. Remember now, the first column name, the second column name, the third, and the fourth one. These are the 4 column names. And we have countries: US, China, Japan, Germany, UK, and India. Here, Americas, Asia, again, once again, Europe, Asia. And the GDP population we have written here. If you run this one, you will get this country here, continent here, GDP, population, and these are the 5 rows. Remember, we have 5 rows and 4 columns, and in column we have these are the labels of the column. Here, index numbers, no label here. Okay, if you want, you can make labels, not a problem. And while doing some kind of data analysis, you might be required to change to labels. We'll go to that later. But normally, this is the standard. Okay. Now, this is so important. I already mentioned you will come across 1,000 times in your data analysis. ILOC. Okay. So, index location, listen carefully. There you might be, confused here, because many times we used already in list, then in NumPy, then in Pandas also you have to use this one. Using index, okay, when you want to take the first row, you have to write ILOC, okay. So df.iloc, if you write 0, you see country, continent, GDP, population. These are the columns, and you got this one, but the first row, but this way, column wise we got. This is the first row. If you write 0, you will get the first row. Okay, you see the first row. If you want, you will write the second row. So taking the index we are finding, not the label here. So this index is there, this index is there. So 1, you write the first row, but in the column wise it shows, but this is the first row, second row. 1 means second row. China, Asia, whatever we had, in second row you see 2 numbers. Then you write 2, you will get the third row. Now you write colon. Colon means you get everything. Everything, when I say all the data. This simple thing is so important and so confusing at times. You will forget for sure. You have to recall 1 second then, but now you remember. Otherwise, you have to practice every day. I lock all here. Colon means all, everything you get. Now, here we retrieve one row. Here what we'll do is, you can write 0 to, suppose, 5 here. Slicing, okay? We got 4 rows. 0, 1, 2, 3, 4. If you do this in a list, that will be different. But here we are talking about rows. 1 row, 0 means 1 row. Unlike a list, if I write a list here, if you remember, even we can write a NumPy also. When you write list 0, 20, 30, 40, Then what we do, we write A this way, then we get everything 10, 20. Then you write 0. So in list, we're talking about single element 4. In NumPy also, we use similar way. 3 means we get up to 2. But here, in data frame, you remember, if you want to get 4 rows, you have to write 0 to 5. 0, 1, 2, 3, 4. The fifth row is not here. If you see here, suppose I write 3, you will get 0, 1, 2. 3 rows. I location 0 to 3. If you make it only 0, you will get the first one. Don't write anything here. Means automatically it will start from 0. That is not required. You mention this one here. Okay. Most of the time you see this way also. Never mind. I'll go to double dot later. Now here another I've written starting from 0 but up to 4 means 3. 3 up to 3 you will get. That means 4 rows you will get. Okay. Then starting from 2 all. Now we are taking only rows. Row slicing here. Now you see again 1. 1 means it will start at 0. Up to 1 means 1 would not be taken. So you will get only 1. But now you see how you are getting the output. This is your column labels. These are the labels of the column. And here we got the first row this way, row wise. Same thing we have done. Okay. 0 to 0. Here also you write 0. But see the output here also. This one they are same. But you get this way the output. That is the only difference. Now you can take rows very easily. iLook dot iLook you have to write. That's all. Now see there is no comma here. So this is where students, people they confuse. There is no comma here. Remember now comes comma. Here there is a comma. 0 to 2, 0 to 2. This talks about row. This talks about column. So you take the first 2 rows 0 and 1. We've taken 2 rows. After that, you take 2 columns, the first 2 columns. First column, this one, and the second column, this one. So, this is a part of data. In list, what we have done? Part of list. Now, here, part of the whole data frame. This is a smaller data frame. I've written BB, I printed this way. Directly, you could have written because you have to know that this is also a data frame. The part of data frame is also a data frame. Okay. So this is the first two columns, smaller one as compared to the original one. So the first thing you need to see is whether you have comma or not. If you have comma, then definitely we're talking about rows and columns both. Suppose I write this. This means what? All rows. See, all rows, comma, here 0 and 1 column. Okay, run this. You got all rows, but only 3 columns 0, 1, 2. Oh, sorry. Here, all rows, okay, all rows 5 and columns 0 and 1, 0 and 1. That way. If I write here this one, then you will get all, whatever you have, you will get all. Sorry, not this one. See, you have 4 columns and 5 rows, everything. all rows, all columns. Then suppose you want these four, only these four. I can show you here this one, this one, this one, this one, or maybe this one, this one, this one, this one. How can you do that? If you want these four, then you have to start rows from here. 1, 1, 3, 1, 3. Let me write 1, 3, 1, 3 here. Here see Asia twice and these two numbers GDP. So that way you can take a part. There is no problem absolutely. Then we'll go to LOC. This is ILOC. Next we'll go to LOC. I for index. So we take the index and we try to take a part of the data frame. Now here you need to remember, if you want to use LOC in place of ILOC, then you have to change, you have to take one label, and through that country was here, bring country here, and this one you make, because 013 will not work. This one you can consider these as labels, index labels, and these are column labels. You have to do this one, not necessarily this one. If you want, you can take any of this. However, if you want to take a new one, it will not agree. The data is same. Okay, the data, there is no change in the data. The only thing is this country was here, this came here, or maybe you can say continent, GDP, population were here, they went here. There is a spacing now. So for that you need to write set index. Okay, if you write set underscore index and country here, then you will get this way. Country will come here. You write GDP here. If you will not work, you go here and restart and run all, it will work. So if you take GDP also, that's fine. We'll see that later. But now see, we'll try to take a slice. Now there is no I. LOC. Okay, DF dot LOC USA. Okay, that means what? Now there is no index level ILOC. Using the labels we'll take. Now we have USA level. Okay, so if you run this, what you will get? See, you had the same data. You will get the same data here as well. You see, America, two numbers. America, two numbers. So if you write USA, of course you have to write quotes. Then you get this one. Continent GDP population, you see, continent GDP population. So if you write USA, then you will get this one. Now all comes, there comes comma now. In comma, what will happen? You have all rows and then you have written population. If you write all rows, then population. If you run it, then all rows you will get. We had 5 rows, right? See, country comes here. 1, 2, 3, 4, 5. How many rows we had? 1, 2, 3, 4, 5, right? Yeah. 1, 2, 3, 4, 5. 6 rows, right? So if you write here all rows. Okay, then you get all rows. Here there are no numbers anyway because we have not written I. Here also there is no number. We take the label. When you take the label here, already you have column labels, population we have taken. Okay, so we have 3 2 and 1 3, the last column numbers we got, because we have exclusively written population here. If you write population, obviously whatever there in the population label column, that will come here with all the rows. Now if you write 2 here, when you have written 2 here, if you check original data, 1 we have taken from here, 1 we have taken from here. It's similar to taking from here 1, this one. Suppose you want to get this element. How you get this element? This element you will get from this row and this column, this intersection, right? Similarly, if you want to get these two you can get from these two intersection and these two intersection, and you have to get those by writing numbers here, index here. Okay, and the same thing you can get through these labels. So China is not a column one, it's an index one. China is here, it's here. Okay, and GDP is here. You got this number, intersection 127700. You can compare China GDP 127700. Okay, so this is the level now. So the first column you need to sacrifice. So if you want to do this way, when you create the data frame, make it sure that the first column has no use here. Okay, that way you can create. You create these separately. You can give A, B, C, D, whatever, so that your data will be there, and you can use LOC and set index. After using this one, you can use LOC. Then comes DF. If you run, you get this one. Okay, then this one is over. You can try in different ways. There is comma here. Comma means, remember, the left hand side will be the index level and the right hand side of the comma will be the column level. Okay, column level, index level. If there is no comma, then it's separate. Okay, individual, like we have written here. Suppose we have written here 1. You can write 2 also. Here 1. You write 2 labels, you get 2. Then when comma comes, row, column things will come. That's all. Now, if you check here, there is a simple graph. This is a simple graph here. Plot. Dot plot. Okay, let me not write all this double. Okay, directly you write dp dot plot. Let's get all. Okay, we have df, and then if you just write your data frame dot plot, we have so many. We'll discuss in matplotlib, because we are not using this feature of data frames here. But yeah, it's a common one, dot plot. So everywhere you will have. So if you just write dot plot, you get a graph and you will have some idea. Okay. Now my question here is, why you got 2? We have how many dot plot? How many here? 3 at least. This one anyway we sacrifice, right? For the label thing, the same data we have done, but you have to use LOC. Means, remember, this way you have to make, okay, separately, so that one column will come here. There is no 0 1 here. You see, there is no index here. Set index when you write, that will happen, okay? That I have shown already. The index will go away, and first column you need to sacrifice. Index also, it will be level. So you have to understand what is your data and how much you need to keep. Another thing here, my question is, if you write plot, we had here 3 columns, okay, GDP, population, continent, 3 columns. Why you got 2 here? If you write specifically 2, you will get 2. But if I have not written anything here, then I should get 3, right? Suppose I will write only 1. I need not write double then. We got 1. Now, if you don't write anything, that means you have to get everything. Why we didn't get everything? That is my question. Anyone? Nibita?
Sir, the continent can't be drawn no, sir, because in Y plot there is a number.
You identified properly, because we have numbers here, and here we have string. Then it's not possible to draw. What you can do is, for Asia you give 1, for Europe you take 2, for America you take 3. That way, if you have numbers, then that also you will get here. However, anyway, uh, these are not included here. These things will come later when we go to matplotlib. There, that will take another 4 or 5 classes. You have to learn properly. Everywhere we'll use. Though these are very easy, but there is a chance of confusion. I'm saying, whenever you try to take someone, iLog and log extensively you have to use. Okay. And this much for today. Class is over for today. I'll send you this document later by today night. Okay, then I'm leaving now. Thank you.